Okay, question 6 says, find the area inside the lemniscate r squared is equal to 4 cosine of 2 theta, and outside the circle r is equal to the square root of 2. Okay, and you can see here in blue is our lemniscate curve, and in orange we have our circle. All right, now if you recall back into section 11.2, we looked at an example dealing with an equation that was pretty similar to this. And there we found the corresponding Cartesian equation for the curve. And there I just noted that the shape of the curve was in fact a figure 8. You can also see it here on Desmos. Looks a little bit nicer there. Okay, now I do want to say before we jump into the area calculation that for a problem like this, okay, I am giving you the information that the shape of this curve is a figure 8 as you see here. Okay, so you don't have to know this off the top of your head. And if it was my intention to have you sketch this curve from just this equation here, then I would make that more explicit before having you compute this area. All right, so now with that in mind, let's go ahead and compute the area. So we want the area inside the lemniscate, right? So inside the blue curve and outside the orange circle. All right, so we're looking to compute the area of this region in green. Okay, now we have some nice symmetry going on here. So what I'm going to do is find the area of this region in the first quadrant. And since we have 4 copies of that region in total, I'm going to multiply that area by 4 to find the total area. All right, so in order to compute the area in the first quadrant, well, the other key thing I'm going to need, right, is this point of intersection between the lemniscate and the circle. So let's go ahead and find that down here. So since r squared is 4 cos 2 theta for the lemniscate, for the circle, r squared will be, well, 2, right? Because r is just the square root of 2 for the circle. And now I'm going to go ahead and equate these expressions for r squared. So 4 cos 2 theta is 2. And so cos 2 theta is a half. And if the cosine is a half, that means the angle you're taking the cosine of, which is 2 theta in this case, has to be pi over 3. And then dividing by 2, you get the theta is pi over 6. And do keep in mind, I'm looking for the quadrant 1 angle here. I know there's more than just the solution of pi over 3 to the equation cosine is a half, but I'm looking for specifically the quadrant 1 angle, so we're good here. So theta is pi over 6. Right, at this point of intersection. Great. All right. So now to compute the area bounded by the blue in the orange curve, right, you want to think about a sweeping windshield wiper, okay, where now the inner part of the wiper is along this orange circle and the outer part is along the blue lemniscate. Okay, so let's set that up over here. So the total area, that's 4 times the area in quadrant 1, as we already noted. It's just using symmetry. So this will be 4 times the integral. And here I want the area bounded by the blue curve, right? So as we sweep through from 0 to pi over 6, right, we're going to pick up, well, 1/2 times r squared for the lemniscate d theta. So theta sweep from 0 to pi over 6. That's going to give us that swept area by the blue curve, and then we want to subtract off from that this inner area, which is 1/2 r squared for the circle. Okay, so the area swept by blue minus the area swept by orange, that's going to give us the area of this green region in the first quadrant. All right, and so now I'm going to go ahead and factor out this half, so that's going to give us a 2 out in front. Right, now r squared for the lemniscate, that's 4 cos 2 theta. So that's right there. And then r squared for the circle, that's just 2. Okay, now I'm going to go ahead and factor the 2 out. So I'm going to get a 4 in front. And integrating 2 cos 2 theta, well, that's just sine 2 theta. And then integrating just 1, that's going to give us a theta. And then evaluate from 0 to pi over 6 and simplify, and we get 2/3 times the quantity 3 root 3 minus pi. All right, cool. And that's going to do it. Thanks so much.